Hi, my name is Jess Stoltz, and this is my presentation on blockchain implementation in the pharmaceutical supply chain. So, the pharmaceutical supply chain is very complex. There are many different players. This is a diagram of the supply chain model for a tablet, and as you can see, there are many different entities that are a part of it, such as the distribution channels, the retail, the manufacturers, the customers. So, it's definitely very complex, and there are many steps involved. Some data that's recorded in it is who provides the material, any testing done to the material, license to manufacture, which is country specific, the demand, manufacturing orders, quality assurance of formulated drugs, and temperature throughout the process, just to name a few. So while the supply chain is great, there are definitely some problems within it. One that I'm going to be focusing on a lot, which isn't necessarily a problem, but it's just a new law that has been implemented, is the Drug Supply Chain Security Act. So this law requires the implementation of an interoperable electronic system to track and trace all drugs through the supply chain. And these parameters are being phased in, but it'll eventually need to be implemented to the entire supply chain. And some of the parameters needed are transaction information, transaction history, transaction statements, and serialization numbers. So it's definitely a big task within the industry. Next is the counterfeit drugs. Between 5 and 8% of the worldwide pharmaceutical trade is counterfeit, and supply chains aren't always accountable for gray market wholesalers and keeping a record of the whole thing, and so it can lead to any corruption or counterfeit within the process, which can be detrimental to patients. And lastly, I'll be focusing on locally stored data, which can easily be lost in the event of a natural disaster. So if all your data is managed in one spot and that spot is hit by a hurricane and that site is damaged, you might lose all of your data. So these are just some problems. There are, of course, more, but I'll be focusing on these. So what is blockchain? Blockchain is a way to digitally share and track assets via a decentralized immutable ledger. So for a supply chain, it can be used to report the status of goods. And it doesn't require that all the data from each company is inputted into it, just some high level and anything that would be needed. The information is stored in blocks, which are bundles of data, and blocks confirm time and sequence of the information. And the blocks are confirmed by a digital signature built from the previous block, and in order to change it, you would need a significant amount of computational power, which generally makes the blocks secure and immutable. And nodes are where the blocks are stored, and each node has all of the information on it, and so no one individual node is critical to the whole database. And this is just a visual representation of some parts of the blockchain and what makes it unique. So some key elements of blockchain that I'll be focusing on are the smart contract, which allows for the exchange of money, shares, goods, etc. with a transparent service that eliminates the middleman. And this is a visual representation of a smart contract. Next are IoT devices, which are sensors to capture and input data, such as temperature, into the ledger. And this builds trust and security because no one's manually inputting it, it's just captured and inputted. And this won't necessarily be implemented for track and trace capabilities, but it's definitely something that can be used in the future. Next is zero knowledge proof, which is the ability to prove to a verifier that you have certain knowledge without revealing the knowledge. So this keeps data safe and creates trust within the blockchain. And this is also a visual representation of zero knowledge proof. And lastly is interoperability, which is easy communication and data sharing between companies despite different technology systems. And so you can plug legacy systems into the blockchain. It's not always easy, but it's definitely feasible. So I think blockchain is the best way to meet the Drug Supply Chain Security Act requirements. The law allowed for the industry to figure out a way to implement it, and so not every company is doing this. Some companies are using the central database patchwork method, but I don't think this is the best method, mainly because there's potential for leakage of business intelligence between companies. It creates one location for hackers to target, and there's no additional return on investment, and there's a lack of funding in place or any method to create funding to create these databases. And so I think blockchain is definitely a better alternative to meet these requirements. Each company would keep their own data, so there's no risk for leakage of business intelligence, and they'd upload what they need to the the ledger of the blockchain, and this can help prevent counterfeiting because you can track and trace product from production to consumption. It's a decentralized storage method, so it helps mitigate the risk of lost data, and it's easy to track and serialize data within the supply chain. And what's also great about this is that the pharmaceutical industry is normally slower to adapt new technology. So because of these requirements, it can be a way for them to test the blockchain and learn its capabilities and then deploy it to the rest of its supply chain and even learn how it can be used to enhance the supply chain in the future. So some other benefits of the blockchain beyond the Drug Supply Chain Security Act are that you don't have to change the supply chain, it just enhances data management and transparency. So you can continue using your current ERP systems, your supply chain management systems, or however you store your data, and it can be maintained and linked to the blockchain technology, and this is interoperability. There's also transparency can be enhanced by smart contracts that allow for key information to be shared between organizations while protecting private data. It creates efficiency and eliminates the middleman. There's a lot of money that's spent on fixing errors, and with the blockchain, you could easily track and trace data with minimal work and minimal time and resources, and that could really save a lot of money and time. It can also track dates such as expirations and deadlines to eliminate oversights, and other parts of the supply chain can be automated within blockchain. This is more of a future implication, but it's definitely something that can be done. It can help detect counterfeit and corruption. Drugs are tracked and logged at all times, so if they're tampered with, it will be known to all. It creates security and trust with some of the elements I explained earlier, such as smart contracts, IoT devices, and zero-knowledge proof. And then lastly, data is decentralized, so it helps mitigate the risk of lost data. So if one node is lost from a natural disaster or for some reason, it's also all stored on all the other nodes, so there's no way that you could lose all of your data unless every single node was lost, which is not something that would probably happen. So implementation is being done. There's something called the MetaLedger project, which is from the company Chronicled, which is a blockchain technology company, and they're creating blockchain tools that help manage the pharmaceutical supply chain. So they're working with companies such as Pfizer, Genentech, McKesson, AmerisourceBergen, and other industry leaders and other technology service providers. And so what they're providing is interoperability. The companies can use their current systems and plug it into the MetaLedger connector to use the blockchain. And they manage their own information internally and share what is needed within the blockchain. Chronicle is also great because they're acting as a neutral software company to oversee the implementation, and they're not trying to own the blockchain, but just to create a space where blockchain can exist within the pharmaceutical industry. And they're working with the industry leaders for live production to meet DSCSA requirements and to help create an industry standard with smart contracts, and they're also employing zero-knowledge proof. So this is kind of a process flow from Chronicled. You can see how data is inputted and what goes into it. And it allows for many industry players to innovate and partake in creating the blockchain. No particular company would own the blockchain, but they work with others in the industry to set standard. And you can see where innovation can be added in the future iterations. And this is just another visual to show what goes into each part of the blockchain, what's recorded throughout the supply chain, and how it really can be used throughout the entire supply chain so that all parts of it can be seen and can be transparent. So while blockchain is definitely great and there are many advantages, there are obstacles for implementing and maintaining it, especially because it's a new technology to the industry. So all players in the supply chain need to adapt blockchain in order to maintain a seamless ledger. And so while there are many manufacturers, distributors, and technology companies that are creating proof of concept for blockchain, not all contributors to the supply chain are implementing it. So an example is CVS Healthcare, which is a large pharmaceutical retailer, and they're not at this phase. Right now they're just researching. They're definitely considering it, but in order to create a seamless ledger, they would need to be on board, and so with other companies. There's also initial implementation costs. So executives at AmerisourceBergen estimate that the cost of the licensing hardware, the storage, and the services will cost roughly $250,000. So this cost would increase for a company that does not have a back-end client system. The industry standard, as I mentioned, it's being worked on by the service providers, and it will be public for use, but it's really important that it is established, and it also is important to create not just a standard, but an environment where all companies use blockchain because, as I mentioned, without full implementation, there will be holes in the ledger. And then data integrity. So any data that's inputted is what's stored. So if garbage is entered, garbage is what is stored. And so companies need to maintain a high standard of data entry in order for accurate information to be maintained on the ledger. And so there are provisions in place such as data syntax verification tools that are embedded in the blockchain to ensure the data meets syntax requirements. And this would alleviate some problems, but definitely not all of them. And then lastly, education. There's always a learning curve with new technology, and blockchain is definitely not an exception. So in conclusion, I think that blockchain is definitely the best way to implement the DSCSA compliance requirements because it's not only something that can be used for this, but can have business benefit beyond it. Chronicle is leading the initiative, and they're working with industry leaders to create a standard. There's always a learning curve with new technology, and it'll definitely need to be overcome in order for blockchain to be successful. And of course, there is an initial cost to setting up blockchain. However, I think blockchain is imperative to the security, compliance, and efficiency of the pharmaceutical supply chain, and it will only continue to improve over time. I think the biggest challenge will be getting all players to be using blockchain and implementing it to have a seamless ledger, but it'll definitely be something that will create a lot of business benefit. These are my references, and thank you so much for listening. If you have any questions, feel free to email me at jgstoltz@gmail.com. Thanks again.